$400 million. That is the sticker on one chip-making machine, and only one company on Earth can build it.
Meet the EUV scanner. It prints the tiniest wires inside the AI chips powering your phone, your laptop, and the data centers behind ChatGPT.
Think of it like a superpowered projector. Light hits a mask, shrinks the pattern, and stamps it onto a silicon wafer coated with special chemistry.
Chipmakers kept shrinking the light itself, from old mercury lamps to lasers to extreme ultraviolet at 13.5 nanometers. That is about 14 times shorter than the previous laser light. Why that exact number? Tin plasma loves to glow there, and special molybdenum-silicon mirrors reflect best there. Physics and engineering shook hands on 13.5.
Resolution equals a process factor times wavelength over numerical aperture. Shorter light and wider lenses mean finer lines. High NA can reach about 8 nanometers.
Here's the weird part. Glass eats this light, air eats this light. You cannot use a normal lens at all. So the whole machine is mirrors inside a vacuum. Stacks of molybdenum and silicon bounce the beam, each reflecting about 70%.
A giant carbon dioxide laser hits tiny molten tin droplets. The tin becomes a plasma hotter than the surface of the sun, and that plasma emits the extreme ultraviolet light.
Collectors grab the light, shape it, bounce it off a reflective mask, then project it onto the wafer. Dual stages keep wafers moving so the fab never sits idle.
50,000 tin droplets fire every second. Each one gets a pre-pulse to flatten it, then a main pulse to light it up. That heartbeat is the hardest part of the machine.
When the main pulse hits, you get a flash of 13.5 nanometer light. Only a few % of the laser energy becomes useful EUV. Source power is everything.
After about a dozen mirror bounces, roughly 1% of the light may reach the wafer. That is why these sources must be insanely bright.
Standard EUV uses 0.33 NA. High NA jumps to 0.55. Better resolution, about twice the price, and a half-size exposure field.
Early nodes used a handful of EUV layers. Today, leading chips can need about 20 to 30. More layers means more scanners, more chemistry, more money.
EUV photons are few and punchy. Sometimes a contact hole simply does not print. Raising dose fixes yield, but slows wafers per hour. Physics always collects a toll.
ASML of the Netherlands is the only company shipping production EUV scanners. 100% of that market. That is a real monopoly, not a meme.
In 2025, ASML booked about 32.7 billion euros in sales and 9.6 billion in net income, with a backlog near 38.8 billion.
The hardest parts are not even public stocks. Carl Zeiss SMT makes the mirrors. Trump supplies the lasers. Cymer, inside ASML, builds the light source.
What can you actually buy? ASML itself, plus customers like TSMC, Samsung, Intel, SK Hynix, and Micron. Then picks and shovels like KLA, Lasertec, and Japanese resists. EUV machines are banned for China. ASML says it has never shipped one there. Advanced EUV is restricted too. This tool is a geopolitical choke point.
In July 2026, Intel started shipping some Panther Lake chips with Select 18, A layers patterned on high-NA. Not the whole chip, but the first high-NA logic product.
Quick myth check. It is not 25,000 times thinner than hair. ASML does not own Zeiss AG, and more than 3 companies buy EUV, including memory makers.
This video is for education only. It is not investment advice. Markets move, numbers change, and you should do your own research before risking money.
If this made chip making click for you, hit like, subscribe, and tell us in the comments what tech topic to cover next. 13.5 nanometers. Mirrors in a vacuum. 50,000 tin drops a second. One Dutch monopoly behind modern AI chips. Thanks for watching.